In this example from number 9, identify the quadratic function graph. We can either just graph each one of these to see which one looks like this graph, or you can convert vertex form, write it in vertex form, and convert to standard form. Now, we're going to convert the vertex form to standard form, and then we'll check it with a match graph at the end. So let's see if we can get the vertex form. Well, it's pretty easy to see that the vertex is this point right here. So I'm going to identify that point. That point looks like 3, 2. So since 3, 2 is my vertex, then that means 3 is my H, and 2 is my K. Right? Now I need one other point on the graph if I'm going to find A. And I'm going to use this point right here. This is one of the zeros actually. Is pretty easy to find. We can use 4, 0. And that's one of the zeros right here. And I'm going to let that be my X and my Y. So what's our vertex form? Vertex form is, again, I think I got it copied somewhere, but I'll just type it. Vertex form is, well, again, Y equals to A times X minus H. And we want to square that. All right. And this is plus K. Well, let's substitute all our values in here. We don't know what A is, but we do have a Y value. Y value of 0. We have an X value of 4. We have an H value of 3. We have a K value of 2. Let's simplify this equation on it. We know that 4 minus 3 is 1. Okay. We know that 1 squared is just 1. So not a to the 1. I don't want that. But if I multiply 1 times a, I'm just going to get that. And I really don't need the 1. So I'm just going to get rid of it. And if a minus 2 is equal to 0, that tells me that a is equal to negative 2. Which makes sense because the graph is opening downward, which indicates that we have a negative a value. It also tells us that we're going to have a maximum. Okay? So, since a is negative 2, we can eliminate choices C and D that have a values of 2. So the answer is going to be out of F is going to be out of A or B. So I'm just going to eliminate this one and that one because A is negative 2 there. A is positive 2 there. A has to be negative 2. So the only thing we need to do now is write our vertex form and convert it to standard form. So since we know that A is 2, A is negative 2, and we know that H and K, H is 3, and K is 2, in our vertex form, our vertex form then is negative 2, X minus 3 plus 2. Let's simplify this. Y equal to negative 2 times expand X minus 3. Let's see if we use the box method here. What's that? 6x plus 9. Close that. Plus 2. course, I need this to be an exponent. All right. And let's distribute the -2. We'll get -2x. This now turns into a 12. This turns into, actually, since it's both negative, this turns to a positive 12. And now we got a -18, right? Let's see, -18, so this is going to be a -18. All right, let's get rid of that 2. And that tells us, if we simplify this one more step, clone, we know that this right here is going to be a -16. So, what is our final answer? Again, our answer turns out to be A, which is choice A. All right. Now, what we could have done also is we could have graphed each one of these and see which one matches the graph. And so, and if you look at the graph of -2, let's look at the graph of that. -2x squared plus 12x minus 16. And especially if I turn my grid on, I like to turn my grid on, -263. And if you can compare that, and I'm going to copy that over. If I copy this over, and I compare this with the original graph, it's going to be big. Let's see if we can get it smaller. You can see that they are the same graph pretty much. Same intercept, same vertex, same everything. So you can always do a graph match.